Hi everyone, this is a demonstration of Skytree 16.0 showing its main capabilities. We will use an example use case of predicting the income of a small group of people. Before we show the use case, what are the main differentiators of Skytree? We believe there are three major advantages that Skytree brings to the user, both the expert and the non-expert alike. They are automation, speed and scalability, and ease of use. Other software has aspects of these, but only Skytree has all three. For automation, our AutoModel searches through the parameter space of multiple machine learning algorithms, and within each algorithm does a smart search through the hyperparameter space. This hones in on the best model much more quickly than a grid search, and finds models of an accuracy equal to or better than an expert user while using much less user time. For speed, our benchmarks show that our algorithm implementations are faster than any others on the market, including command line libraries normally only used by experts. These speedups are achieved by mathematical reformulation of the algorithms and not by approximations. For scalability, we have run our fully nonlinear machine learning algorithms such as gradient boosted trees on training sets of up to 1 trillion elements, 10 billion rows by 100 columns. The trends seen on the distributed computing system we used indicated that the software easily scales to even larger than this. For ease of use, all of our speed, scalability, and automation are available in our graphical user interface so that the power and accuracy of our approach can be accessed in a few clicks. For expert users who want programmatic access via SDK or command line, this is also available. Now that we have seen Skytree's differentiators, let's see our use case. In this business problem, a company wishes to use census data to predict people's income for marketing purposes. They would like to predict whether people earn less than or greater than $50,000 per year, and why. This will enable better and more targeted marketing efforts. We will build a supervised machine learning model to predict income for this company. This will be demonstrated by the graphical user interface of Skytree. After logging in with our user credentials, this gives us our main projects page, on which we can see a number of projects in progress that are solving different business problems. Click on the income project to access it. Within the project, a number of datasets are visible, including the raw data, data with an added ID, and the training and testing sets. For each dataset, we can view the data by clicking on its row entry and selecting Data. This brings up a display of the data table. We see immediately the variety of different data types that are present: numbers, categories, discrete and continuous values. Skytree also handles text, time series, sparse data, and missing values. In these data, each row represents a customer, and each column is a piece of information or feature about them. Scrolling over to the rightmost columns, the column that we are shortly going to predict is the one labeled yearly income. This has two values, less than or equal to 50K, meaning that the person earns less than $50,000 per year, and greater than 50K, meaning that they earn more. We therefore have, for this use case, a binary classification problem. The data that we are viewing forms the ground truth for the problem or training set. Skytree automatically holds out a portion of the data so that we can see how well our model generalizes. This is of course what we want when the new data arrives after the model is put into production. We now turn to our machine learning models. Skytree is designed to enable the easy and rapid creation of the most powerful machine learning models available, but also to give you full transparency and fine-grained control if desired. We are going to create a new machine learning model using the income training data to see how well we can predict whether our new unseen people have a low or a high income. To measure the model performance, we of course need to know whether the people for whom we are predicting really do have a high income. To serve this purpose, we hold out a portion of the training dataset so that we can assess the model against it. To create a new model, select New Model, select the dataset to use, give the model a name, or use the default, and select the column to predict. We are going to predict whether or not a person has a high income. This brings up the model specification page, allowing us to choose which machine learning method to run. Creating a powerful machine learning model in Skytree can be as simple as choosing AutoModel, which is shown as the default, and clicking Learn. We find in practice that such models are often competitive with the best expert efforts, even of expert data scientists. At the bottom right of the page, Skytree's automatic feature engineering is available. To enable this, simply check the box and run the model in the same way. Currently, the feature engineering is quite basic, but it will rapidly expand in future releases. AutoModel is also able to perform prerequisite transformations on the data so that algorithms that require numerical data, such as support vector machine, can still be run even when the input dataset has non-numerical data such as categorical variables or missing values. Finally, at the bottom of the page, we see that Skytree automatically calculates the amount of compute resources required for this job. For a Hadoop system, this is given in terms of yarn containers. This calculation means that users can use a full distributed system from the GUI without needing to know details about the memory, containers, and so on. Skytree automatically deals with this and does not exceed the resources allocated. In this demonstration, we have already run the machine learning model, so we can view the results. We see that three machine learning methods were run: gradient boosted trees, or GBT, generalized linear models, or GLMC, and support vector machines, or SVM. The best model in this case is the one with the highest Gini score, which is a measure of how well the low and high income classes have been predicted. Here, GBT is the better model, and it reached the best value on the 19th iteration. While both methods do quite well, the algorithm concentrates on the superior GBT while placing less emphasis on SVM. This shows the important point that AutoModel is much more sophisticated than simply running a set of models and choosing the best one. Note also that each point on the graph represents a complete machine learning run with training and holdout set or cross-validation. If the user wishes to continue the search for some more iterations, Skytree has the option to continue training using the results found so far. The results of the model are available in tabular form in addition to graphical form, with the best model marked by a yellow star. Note that for both the graph and the table, the results so far are available as the model is being run, and the user can watch the table being updated in real time. Moving on to the audit trail, this illustrates our project so far. The audit trail is a significant Skytree differentiator as part of our ease of use and enterprise-grade functionality, because, while other software can diagrammatically represent a data flow, Skytree is the only environment that combines the speed and scalability of advanced non-parametric machine learning methods to billions of rows, enterprise-grade software deployment, ease of use, and full documentation represented by the audit trail. Within the trail, the rectangles represent datasets, the rounded rectangles models, and the hexagons results. The trail has a number of uses, including keeping track of one's projects, returning to them after a period of absence, showing or passing the project to peers, recording cumulative modeling experience and intelligence for the company, reporting to others such as management or for regulatory compliance, The right-hand side shows full details about each step of the process, including unique file identifiers and full model and dataset information. We can view further details about the results of our model. The Results tab shows the application of our model validated using holdout data from the training dataset to unseen data on the testing set. This shows on the left details such as the confusion matrix, and on the right the ROC curve of true positives versus false positives. In this case, we can see that our model has generalized well to new data. There is also the ability, if you can estimate the value of correct and incorrect predictions in your business problem, to give your model a dollar value by enabling our cost-benefit weighted evaluation. This gives a nice bottom line result of your model for its justification or a succinct summary. If we wanted to apply our model to further data, we can use the predict and evaluate functionality within the UI. AutoModel can be deployed by Skytree in production using its PMML output or other options. Now that we have our model and we have demonstrated that we can deploy it to new data, to close the circle and return to the question of income and what action to take for each person, we would like some insight. This visualization shows the Skytree decision tree machine learning model. Each data point comes in at the top and is propagated through the tree. In fact, Skytree has generated a whole ensemble of trees. But we will focus on the first one. The notion of which variables are the most important in the model, and hence why it is making the decision that it is making, is measured by variable importances. Here, the higher the importance, the darker the tree node. For the example shown, the customer has a non-marital relationship, low capital gain but good education, and works less than 43 hours per week. The score value means that they are less likely to have an income of greater than $50,000 per year. In comparison, if they work more hours per week, the score now shows that they are more likely to earn more than $50,000. When we view the overall importances, we see an interesting story. While variables such as capital gain and occupation are predictors of income, as one might expect, the most important predictor of income is one's type of relationship. Thus, from this analysis, the model is telling you to give almost twice as much weight to people's relationship as any other variable if you want to target people most likely to have high income. Variable importances give the overall significance of variables in the whole model as one value. To gain additional insight, we can plot the partial dependence plots of variables. These show the effect of changing a variable within the effect of other variables being factored out. In the age example shown, this means that between 20 and 40, with other variables factored out, income on average rises due to age alone, then flattens out between 40 and 60. It then drops slightly, presumably due to retirement. The plot to the right, education, shows income rising as number of years of education increases. Plots can be shown for continuous or categorical variables, and in one or two dimensions. In 2 dimensions, red means more likely to be higher income, and one can see the interaction between 2 variables. If the variable is of high importance, this is giving you even more insight into your model. For example, the middle plot on the bottom row is showing you that, regardless of occupation, husbands or wives are more likely to have higher incomes. In conclusion to the business use case, we built a supervised machine learning model using Skytree to predict whether people earn less than or greater than $50,000 per year. The model classified about 85% of the people correctly. The most important reasons for income level are the type of relationship they are in, capital gain, and occupation. The probability of low or high income and the reasons given determine the most appropriate course of action for the company to market to each person. The customer wins from receiving better marketing, the business wins via more focused and successful marketing, and the business earns more money by deploying Skytree. Finally, as part of our end-to-end data science platform, we allow arbitrary data preparation at scale using transform snippets, which can be previewed or run. The preview adds interactivity to the analysis, and snippets the flexibility for the user to fully solve real-world machine learning problems. As well as running on your own computer or in-house system, Skytree is also available on the cloud via Amazon Web Services. In particular, we have a process called elastic machine learning, which allows a job to expand onto more machines if it turns out more computational resources are needed, within limits defined by the user, of course. To conclude, we saw a business use case, and now we reiterate Skytree's main differentiators: automation, speed and scalability, and ease of use. Most important of all, and our greatest differentiator, is that we combine all 3 of these into one system. Thanks for watching, and we hope you enjoy using Skytree.